Hello everyone, so now let's discuss inequalities. So inequalities are statements in which two expressions are related by an inequality symbol. So, what are the two types of inequalities? Okay, two types of inequalities are strict inequalities. So we use the lesser than and the greater than inequality symbols for that. And we also have the non-strict inequalities where we use the lesser than or equal and the greater than or equal inequality symbols. Okay, so let's say we have integers, real numbers a and b. So we say that a is lesser than b if b minus a is positive. So take note that a lesser than b is also equivalent to saying that b is greater than a. Okay, so let's take a look at that in the real number line. So, oh, it's too big. Okay, so in the real number line, so let's say we have let's select two integers here, 5 and 1. Okay, so let's try subtracting. Let's say that 1 is a and b is 5. Okay, so b minus a would be 5 minus 1. So since this is positive, so we can say that a is lesser than b, or have here 1 is lesser than 5. And then it's also equivalent to b is greater than a, or 5 is greater than 1. Okay, so what if the two values are on one coordinate? So let's say a and b are both here in -4. So if that's the case, then we say that a is equal to b. Right? Because they have the same value. And if we take b minus a for that, we have b minus a is equal to 0. Okay. So with that, we have established the order in the real number line. Okay. So if we take two integers, the real numbers b and a, for example. So the one on the right side of the number line, b, greater than the one on the left side of the real number line, which is in this case is a. Okay. So let's now proceed to graphing inequalities. So graphing inequalities. Now let's say we were given the statement x is greater than 1. Okay, so x is greater than 1. So what do we mean by this? So in order for this statement to be true, what are the values of x that will satisfy this statement, that will make this statement true? So we have x is equal to 1.1, right? 1.1 is greater than 1. So we also have x is equal to 1.2, or x is equal to 1, or x is equal to 3, x is equal to 4. So you can go all the way to positive infinity here. All the way to positive infinity, right? So if we graph that on the real number line, you can say we start from 1, right? So if it is a strict inequality, a strict inequality, so greater than is a strict inequality, right? So if it's a strict inequality, then we use this symbol right here. Okay, it's like an open parenthesis. This means that 1 is not included. So the values that we are concerned here are greater than 1. So, and we draw a line here indicating that it's going to positive infinity. So these are all the values that make the statement x is greater than 1 true. All the values of x are greater than 1, but it does not include 1. Okay, so let's give another example. Okay, let's just use this number line here. So let's say x is lesser than negative 2. Okay, so x is lesser than negative 2. Okay, so we're still going to use the same notation. The same number line here. So we can graph it by using this symbol right here, and then drawing a line up until to negative infinity. So because all the values of x that satisfy this represents all the values of x that satisfy this inequality, that make this inequality true, right? So negative 3, negative 4, up to negative infinity. So we have here x negative lesser than negative 2. Okay, so let's now move on to non-strict inequalities. So non-strict inequalities. So let's say we're given an example, x is greater than or equal to 3. So greater than or equal to 3. Okay, so let's show that in the real number line. So how will we graph that? So for strict inequalities, because this includes 3, right? Because greater than or equal to 3, we have a different symbol for that. It's like a open bracket right here. So this is how you graph a non-strict inequality. So this is x is greater than or equal to 3. Okay, so this is the symbol that we're using. This is the symbol that we're using because 3 is already included. So to indicate that, so if this was a strict inequality like this, so we will be using this symbol, right? So this is the difference here. So another example. So let's say x is lesser than or equal to 0. So x is lesser than or equal to 0. So let's 0 here. So we include 0. And then we draw a line up to negative infinity. Okay, so this is x lesser than or equal to 0. Okay, so those are the inequalities and how to graph them. So we also have a combination of these inequalities. Okay, there are also instances where there are combinations, so this is very common. So let's say, for example, we are given x is greater than negative 1 and x is lesser than 3. Okay, so there are two inequalities here. Okay, so we have to satisfy both of these. X is greater than or equal to negative 1, x is lesser than 3. So we can also rewrite this as x. We put x in the middle, greater than or equal to negative 1, and x is lesser than 3. So this is the same as this. So how are we going to graph this in the real number line? So let's see. So x be greater than or equal to negative 1. So we know that that. So -1, we have this, right? And x should be lesser than 3, right? So have here 3, it does not, we do not include 3. So we draw a line from -1 to 3. So this is x is greater than or equal to -1, lesser than 3. So this is the subset of the, say, let's say, this is a portion of the real number line that makes this statement true. Okay, so this is the portion of the real number line. Okay, so that's how you graph that statement. So let's give another example. Let's say x is lesser than -2, lesser than or equal to -2, and greater than or equal to -6. Okay, so let's plot it in the same number line that we have here. So it's greater than or equal, so we will use this bracket, and then greater than -6. So it's greater than -6. Okay, so we will then connect it here. So this is our graph for x is greater than or equal to -6 and lesser than or equal to -2. Okay, so that's how you graph these inequalities in the real number line. Okay, so in the examples in the module, so we also have given examples like this in number 2. We have describe the following using inequality symbols. So A, x is at most 8. X is at most 8. So what does this mean? So it's asking us to express this statement into an inequality. So x is at most 8. So 8 is the greatest value of x, right? So does that include 8? Yes, because it says at most 8. So it includes 8. So what are the values that are included here? All the values that are lesser than 8, and then it includes 8. So how are we going to say that in inequality? So x is lesser than or equal to 8. If x is at most 8 means that 8 is the largest value. So it includes all of the values that are lesser than 8 up until 8. Okay? So let's have another one. Okay? So for letter D, I have y is at least -5. So at least -5. So that means that -5 is the smallest, right? Is the smallest number in this particular range. So let's say x is, since -5 is the smallest, so greater than or equal to -5. Okay, so it includes all the values from -5 up to positive infinity. So all the values that are larger than -5. Okay, so that's it for this video. We will continue in the next section for intervals.